So, hello everybody. Welcome to the webinar Clear Skies Ahead, Global Innovation in Aviation Decarbonization. And I think we have about 2 hours now for discussion. You will also have the opportunity to ask your questions in the chat. So I really encourage to get into the discussion with the panelists, and as more interactive it is, the more insightful and maybe also the more fun will it be for the next close to 2 hours. So the panelists for today are Oscar Meyering, Head of Future Fuels of Sky Energy, Gema Haru, Head of Environment Divisions at Enair, and Gunnar Hohlen, CEO of Nordic Electrofuel. Myself, I'm Valentin Batteiger. I coordinate the future aviation fuel research at Bauhaus Luftfahrt, a think tank dealing with civil aviation in Germany. Now, I will ask in the first round of questions, or maybe a round of introduction now, the panelists to introduce what they are doing and what their companies are doing in this field. So Oscar, maybe starting with you.
Yes, thanks, Valentin. Good afternoon, everyone. My name is Oscar Meyering. I'm, as Valentin already said, heading the Future Fuels team at Sky Energy. And for the ones that don't know us, we are a company fully focused on sustainable aviation fuel development. So we started originally in 2009 by, amongst others, KLM, to develop the market for sustainable aviation fuel. And fast forward to today, we are basically doing two things. We buy and sell sustainable aviation fuel. So for our own project, but also third-party projects, we would like to source and purchase the fuel and then sell that to our airline and corporate customers. And then on the long-term side, we develop new production capacity. So we look at potential new locations, potential new feedstock technology combinations to see where can we develop a new production capacity, new facilities to then produce sustainable aviation fuel. And to stimulate that, we also work on some advisory work. So personally, of which, for example, the UAE is a very interesting one for us. But also we do advisory for partners and clients where we try to help them get their first steps in the world of sustainable aviation fuel. So very happy to be here today, and hopefully we can have a nice discussion, and feel free to ask anything related to the topic.
So thank you, Oscar. Gunnar.
Yes, thank you. Thank you, Valentin. So my name is Gunnar Hohlen. I'm the CEO of Nordic Electrofuel. My personal background is that I worked 31 years in investment banking. Actually have co-founded and been CEO of 2 investment banks. I started in Nordic Electrofuel in 2016, which was about half a year after it was founded. So we were one of the early pioneers, or maybe the first pioneer into the e-fuel business. We've been developing our technology and our business since then. We developed proprietary technology. We have two patents being awarded to us. We have one plant which is basically ready to build at the industrial park in the southern part of Norway. We have a portfolio of other plants to be built around Norway, and we have actually, it's interesting to be here in this seminar where we focus on the Middle East. We have I think sort of our technology been known, so we have actually had several calls and discussions with sort of representatives from several of the countries in the Middle East, and we see that as a very interesting market for us to make future plant, as this region both holds very much affordable renewable power and CO2, which you can reuse. So those are the main components for making e-SAF. Also mentioned that we, for our first plant, we received the support from the EU Innovation Fund, so we are officially co-funded by the European Union, and we scored very high. We had a significant DD on a company. We sort of delivered 700 pages to the European Commission, and we scored extremely high, 82.5 points out of 90. So I think that sort of verifies some of the technology we do have. So that's me. Thank you.
Thank you, Gunnar. So both Oscar and Gunnar have a background in sustainable aviation fuels and their production, and also thank you to already highlighting here the potential that we have in the Middle East, which I believe is a special region for the development and maybe even for the early development of projects in this field. Now, we also have Gemma with us with a completely different background. So Gemma, you can introduce to yourself. You're still muted.
I was saying that thank you. First of all, I want to thank the invitation for this webinar. And I'm the head of ENAIRE, the head of environment unit in ENAIRE. ENAIRE is the Spanish ANSP, so a different area. And it's the fourth ANSP in Europe, and it controls 2.2 million of kilometers of the Spanish airspace. In the environment unit, we work toward to get the common objective to get this net zero in 2050 for emissions. And what we main work is in trying to get more efficient routes and more efficient operations in our airspace. We work with different European groups in trying to achieve this climate neutrality. So thanks for this opportunity.
Yeah, I think this thanks goes to the organizers, not to me as a moderator. But Gemma, you mentioned something important, and this is the target. So you mentioned that the aviation industry, IATA, ICAO, both announced a target to operate on net zero carbon emissions by 2050. So other people have climate neutrality targets and so on. But the big thing here is that aviation as an industry wants to become at least carbon neutral until mid-century. This is only 25 years to go. So now operational efficiency measures are different from the aviation fuels. But at the end of the day, maybe we will need both things. What is your position? How would you rate the various options that we have to achieve this target?
Well, we are studying about which are the rates for all these options, because here are different sectors, but we must work together toward a common objective and different stakeholders. There are airports, there are manufacturers, there are airlines, there are companies. All we have to develop different measures and how can we work. There are studies that said that, for example, ANSP are able to reduce around 6-10% of the global emissions, and we have to develop all the measures toward these objectives, these 6-10%, depending on. And our great hope is SAF, and this is around, I think, if I'm not wrong, it's around 40% of the capacity for reduce emissions. So we must work together and try to get this objective.
But maybe sticking a bit with this operational efficiency. So you said some 6%, maybe a little bit more. But what kind of measures do you have in mind? Maybe 1, 2 measures that you believe could be most effective also for short-term reductions of fuel burn?
Yeah, we must work in horizontal and vertical efficiency. And we are working in the designing of new aerospace. I suppose that you heard about SES and Clean Sky. What we are working to try to work with all the other European ANSPs, just to work toward this objective. And in horizontal efficiency, we are working with a more efficient operation, more efficient routes. And in vertical efficiency, we are working with what we call CTOs, a continuous climb operation and design operation, and trying to optimize the flight levels. But I always say that when we talk about emission, we have to think in the global perspective. For example, in European, we have a very, very strong policy about noise. So sometimes we have to compensate or be able to compensate emission and noise, and how we can implement this measure with this taking into account those interdependencies.
Yeah. So before we go into the details of that, I think that's interesting questions also highlighting kind of the trade-offs between operational efficiency and different operational targets that we have. Maybe we come back to the fuels so my feeling is an operational measure, efficiency measure is something that in many cases pays for its own because it reduces the fuel burn. So there is clearly an economic incentive to go that way. But on the other hand side, when we look into the past, we had operational efficiency improvements. We of course also had like a lot of technological efficiency improvements in aviation, but fuel burn was growing. So these efficiency benefits were usually outpaced by demand growth. So I guess most air traffic forecasts expect that this will continue. So what we will likely see is like an increasing baseline of fuel burn that we will have, and this leaves us then with a substitution of these fuels as mainly let's call it the only measure to bring this then to zero. But on the other hand side, with the fuels, it's different. Yeah, here we clearly pay higher price level, at least at the beginning, for the environmental benefit. And my question, and maybe I start with you, Oscar, is what is your perspective on the cost side? So do we have a chance to be cost competitive with the conventional fuels anytime soon?
The real honest answer is probably not. So I think sustainable aviation fuel is a product that is more expensive than fossil jet fuel, on the basis that we know today, right? So that's without taking externalities into account. So you can either do two things. You can pay that premium that is necessary for the sustainable aviation fuel, either through market-based mechanisms like or policy-driven mechanisms like a mandate or potentially incentives in the early days. Or you can say, well, the fossil side needs to pay a penalty for the environmental, let's say, effects that it has. So then it's more an environmental tax or a CO2 tax. So those are two mechanisms to potentially solve that issue, but we'll probably come to that in terms of how we can solve these things. But the basis is now that the products that we are creating are more complex and therefore more processing is needed, and the feedstock is more expensive than fossil jet fuel. And that's a very developed technology. It's a product that we know very well and can cheaply, let's say, convert into jet fuel. But if you start from used cooking oil as an example, or if you start from woody biomass even, or if you start from CO2 and hydrogen, then all these pathways are more expensive than fossil jet fuel, and that will remain to be the case if you don't have these other effects to stimulate or penalize the other side.
Yeah, I think this is a very clear message that you were sending, and it's also to the experts in the field, no surprise. Yeah, I mean, this is what everybody agrees on, that these fuels will be more expensive for the time being, and of course, this is also something that we see in the market. Still, now we have production coming online, and you mentioned a lot of potential regulatory measures that we can have to induce this demand. But on the other hand side, there's also company policies and so on that that do something in this direction. And I would like to kind of postpone all these questions to a later stage, and maybe stick a little bit with more the basics, like the technologies at the beginning. So coming now to you, Gunnar, is now when we see this, yeah, that the cost of these fuels are higher, then we clearly need to justify the introduction of these fuels, and the justification here is the environmental benefit. But we also need to keep in mind the consideration of the scale. So the scale where we need to go, so global aviation fuel burn being at 300 megatons per year at the moment. And many people believe that e-fuels will be one of the key technologies to really deliver the fuel volumes at this scale. So what is your perspective on this cost, sustainability at scale issue, and what can the e-fuels deliver there?
I think that we all need to be aware that e-fuels or sort of any other SAF will be quite a bit higher than fossil fuel. I think fossil fuel is very inexpensive. I mean, to think about it, you pay $0.50 for a liter. That's basically the price. It's no way that you can compete with that with eSAF or any other sort of SAF. I think also one should bear in mind that if you look on the airlines, what are their main costs? It's not the cost of the fuel. I mean, that's 20 to 30% depending on where that airline is flying. So, you know, even if you double that, that's not really the high cost. The really high cost for airlines is the cost of new planes. So, and I think also you can see that the development of eSAF is sort of enabling us to fly. If you do that 100%, you can fly. E-fuel is 99.9% emission-free, emission avoidance. So, you know, it's most, I would say, it's the most valuable of the SAF, because some SAF is only coming to 70%. So I think we just will need to say, well, you don't get this parity, but the good thing is that you can utilize the current planes, and that is what really is costing the airlines the most. And then you can also say, well, you have alternatives to current airplanes, then you go the route to doing like hydrogen planes. And there's no hydrogen plane in the world yet. There's some prototypes. That is really a long haul. I mean, the best project, as far as I know, is Aviation. They will have a prototype carrying 19 passengers in 2035. Imagine what sort of cost that would be. We're talking sort of tenfolding the ticket prices if we are to go the hydrogen way, because then you need to put up hydrogen at all sort of airports. We are in principle, we are making hydrogen. We just add in CO2, which we capture, and then make it to a product which all aircraft today can utilize to 50% of our fuel or SAF. And when you get the new engines on board, you can actually go up to 100%. So I would say we are, even though our cost is quite a lot higher, we are enabling a very low cost for doing the energy transition, because the alternative is not to continue on fossil. I mean, that's out of the way. I mean, then we do this 5 degrees global warming, and then sort of the world will not be livable in many places. We may be fortunate in Norway where it's quite cold, so we won't have this very severe heat that Southern Europe and the Middle East faces. But still, I mean, that's not a scenario we can have. So one need to be prepared that flying sustainable will incur a higher cost. I mean, that's for sure. I mean, we would do our utmost to reduce the cost of our fuel, and for us, it's about we're starting with a small scale, and obviously by having a sort of small plant initially, 8,000 tons, that incurs a higher cost. So one way of reducing cost is going to bigger and bigger, and we already have model sort of full-scale plant in the range of about 200,000 tons, and certainly we can increase from that, and it's about getting enough renewable power, and that's what we need in the world to get the cost of renewable power down, because 70% of the cost for ESAF will be power. So obviously in northern Norway, northern part of Europe, we're talking sort of 50 euro per megawatt. Best areas maybe be sort of 40 euro. I think by developing new wind power and new solar power, you can get down to 25. That can certainly euro per megawatt. That is what can really bring down the cost. So sort of a solid or massive development of renewable low-cost power in terms of solar and wind in the best regions. That's the way to bring down the cost. But I think people need to be aware that flying so far is quite inexpensive. I pay approximately the same price for an airplane ticket now that I did 30 years ago. So you can say it's been quite a good achievement by the airlines to keep the prices as they have been, and I don't find it expensive at all to fly. So I think some added cost that's we all need to. The energy transition is sort of not something which is coming for free. I mean, that's a cost on everybody, and that's for much more than aviation. That goes with sort of all levels. I mean, transport on land across the regions need to be electrified. That has a higher cost. So yeah, I think that's the case. One needs to understand this costs more. It costs more to go to do energy transition, and that has a cost.
Yeah. So of course you are the CEO, so for you the cost to fly isn't too painful, but this is different, of course, for many people in the world. But what is also important to mention is that we have these particular cases where, for instance, in Norway, maybe it's not too painful to pay this extra premium, and where we see, for instance, in short haul markets, the fuel cost is not as relevant as in long haul markets and so on. So there's very clearly, and the same thing maybe for cargo, which has a higher willingness to pay. So there are differences, and clearly there are a lot of cases where there is just enough money available to pay a premium here. So you introduced to a lot of things, Gunnar, and I would like to hear Gemma's perspective on electric aviation and also the hydrogen aviation that you were mentioned. But before I go in this direction, I would ask you maybe for a short answer to give a typical indication on the timescales that are needed to develop these plant capacities that we need, because this is another relevant aspect for me. So if it would not be about this time scales, one could say, okay, let's let the other sectors do their transitions first, so aviation gets a free ride on other sectors, bringing the cost of solar and wind power down, also for the electrolyzers and so on. But when we want to achieve our 2050 targets at the scale we need, then we also need to timely start with the development of the SAF capacities out there. So can you quickly elaborate what is the typical time scale to develop a plant and then get the learning and get to the next scale and so on?
No, yes, for sure. I mean, we've been working now 8 years to develop our first plant, but obviously that's sort of been a long learning curve. But typically to develop a project, it's 3-4 years of sort of doing studies, securing agreements, and then you have 2 to 3 years building period. So from you start a project to you are concluding on that, I would say it's easily 5 to 6 years. And that's sort of the time you need. I mean, but we can, if you go specifically to us, I mean, we'll start our first plant, start construction on that in the end of next year. Then it's 2 years building, and then it's half a year of building up the production, the commissioning. We also have, I mean, have been working and are working on many other plants. So we do have a roadmap in Norway to increase our capacity from this initial 8,000 tons to 800,000 tons. So I think that corresponds to approximately 2% of the capacity needed in Europe overall. So it's something, but it's not a lot. And there we have a time plan to do that for 10 years.
Okay. Thank you. Now, Gemma, as said, other sectors do differently. So nobody does synthetic coal to preserve a coal-fired power plant or something like this. Also, on-road transportation, we see a strong push into electrification. So I think what we are just about to see is another revolution when it comes about electrification now of heavy-duty road transport and so on. But in aviation, we are pretty much fixed to this drop in synthetic fuels. So what is your perspective there? So, and specifically on this very non-dropping things like electric aircraft, like hydrogen aircraft, what role do you see for these alternative, and what do you think are the time scales where they can come into play?
In my opinion, our time scale is higher than other sector due to safety. I think aviation is one of the safest sector of the world, and it needs to be really proved to be implemented. So for that reason, I think that SAF, then more or less, I'm not the expert in SAF, and maybe my colleagues could answer that, but SAF is a great hope because it doesn't need any technological change. So this is the great hope. These technological engines or new kind of airplanes like electric or hydrogen engines, it could be we need more time to be developed and to ensure that are safe. So for that reason, our time scale is higher than other sector, and this is why we have find a great opposition in society, because we are not in aviation. Around 2% of emission came from aviation in the world, and we are not the higher emissions, so we don't create the higher emissions, but we have a great opposition with society, and it's because our evolution is we need more time than other sector.
So this is for hydrogen and for electric aviation. Do you see a future for electric aviation?
Yeah, I think it came, but maybe I will not alive when it will be. But I suppose that this is going to change. Of course, they are working. I know that Airbus and Boeing are working on it, but we need more time. I don't know, 30, 40 years. I'm not sure.
Yeah. What we see in our studies is that electric aviation, so from the engine perspective and from the power electronics and so on, it's not a big deal, but it all comes to the batteries, and that battery weight is really painful there, and you can do it, yes, but very likely it will be severely range limited for the time being, and so it's also only a solution, I would say, at the moment for the very short haul flights. Oscar Gemma has said something about the safety. So for aviation fuel experts, we don't expect a lot of safety problems. I would say maybe even safety will increase in the long run because we have cleaner fuels. But maybe you can say something here about the details about what levels of blendings are okay, what the safety considerations are, and maybe also, I hope I don't catch you on the wrong foot, say something about the perspectives of fully synthetic fueling in the future, because when we want to become climate neutral, we need to overcome blend walls, and we want to use like 100% renewable fuels in the future.
Yeah, that's a good question. It has quite a couple of components. So let me try to, let's say, distill it in a couple of, let's say, topics. So first of all, for the ones that don't know it, within aviation, the safety is typically regulated by governmental bodies / aviation institutes. And one of those is ASTM, is the American Society for Testing Materials. And they are quite far advanced in, let's say, qualifying and or certifying new production pathways. And production pathways is typically a feedstock technology combination. And you need to go through quite a rigorous process of testing. And that testing takes place together with the OEMs like Boeing, Airbus, Rolls-Royce, the others, to make sure that the fuel you use is of similar quality and of similar performance as fossil jet fuel. And that process is done by ASTM and then often copied or taken along by other, let's say, more national or regional safety bodies like DEFSTAN in Europe, more on the defense side, or you have Chinese specific bodies and other regions. The UK has their own. But in the end, it's about qualifying new pathways and making sure it adheres to the right quality of fossil jet fuel. And if you then start looking at what was initially certified, it was Fischer-Tropsch, based on CESL, but also HEFA was a pathway that was quite early on certified for use. And HEFA is a pathway that's being used by using veg oils or waste oils. So, for example, used cooking oil is a typical feedstock for that. And you create a fuel that is very similar to fossil jet fuel, but it does not contain aromatics, so cyclic structures. And to avoid that and to be 100% drop-in, let's say, you first need to blend. So you can use that product, the pure, we call that synthetic blend component, SBC, and that needs to be blended with fossil jet fuel. And for some pathways for most pathways, that's up to 50%, 50%. For some pathways that are different in composition than fossil jet fuel, you can only blend up to 10% or 30%. And that depends a little bit on the quality and the initial composition of your synthetic blend component. And then after blending, it's called a SAF. And then it's a full drop-in and can be used in all the equipment, all the infrastructure, and all the aircraft that are existing today. So there are currently, I think, 8 pathways qualified, ranging from HEFA to Fischer-Tropsch, as well as alcohol pathways like ethanol to jet, isobutanol to jet. There are still a couple of pathways in the making. For example, methanol to jet is a topic that is currently quite high on the agenda of ASTM, and is being developed by a number of technology developers. And then there is also discussion to come to your next question on when can we come to, we're far away from 50% blend limits at the moment, right? So it's not an issue in the industry yet, where it is already an issue in, for example, ethanol markets. This product is very similar. So 50% is quite a high blend wall, and we're only below 1% in the world still. So there's still a lot of room for growth, but we're already as an industry looking at what can we do beyond that. And then we're talking about 100% use of SAF. And there's basically two tracks. Either it's you combine certain pathways that create then a fully replaceable fuel from fossil jet fuel, so including aromatics. So you, for example, use another technology that does produce aromatics and mix that with a HEFA type fuel, which does not contain aromatics. And then therewith you can create a SAF product that is fully the same as fossil jet fuel. Or there is a pathway ongoing 100% what they call non-drop-in, and that's more like a 100% use of a HEFA product, which does not contain aromatics, in the existing infrastructure. And that's a little bit further away from reality. I'd say it will take years to get there, but there are already quite a lot of testing ongoing in, for example, use of 100% SAF in aircraft, and especially in newer aircraft, we don't see a lot of issues. Actually, it works quite well, and it actually works a bit more efficient. However, it will need a lot more testing before that can be used. So there are, let's say, pathways itself with their respective blend limits, and then there are a couple of activities ongoing to see whether we can increase either blending together certain SAF pathways or in future potentially segregated or integrated in all the existing infrastructure, and a fuel that is not fully the same as fossil jet fuel, but that's a little bit further away.
Thank you, Oscar. I will ask you the next question, and I will now give some background information, and you can then just say if you agree or not agree. But Oscar mentioned these aromatics. So what are these aromatics? So the fuel usually contains different molecules, and these are usually hydrocarbons. And one class of these hydrocarbon molecules are these aromatics, and we find them in the fossil jet fuel that is derived from crude oil. But we usually don't find them in the sustainable aviation fuel production pathways, at least not in their most, let's say, direct and economic way. So HEFA pathway, alcohol to jet pathway, Fischer-Tropsch pathway, methanol to jet pathway. So in first place, they do not produce these aromatics, and this is a benefit. So it is a benefit in terms of non-CO2 emission. It's a benefit in terms of air quality at the airport environments. It's a benefit in civil aviation also because of energy density. So the fuel has a slightly lower density. So the aircraft will be a little bit more efficient in the future. And this is why people are now preparing also for this non-drop-in alternative. But this non-drop-in alternative then also means, not now, I think, but maybe in 15 or 20 years from now, that we will likely then need to see a shift also at the airports, where we need to have kind of a transition time, where we don't have a single fuel anymore at the airport, but where we need to have kind of a in-between time where new aircrafts are capable of flying with the new and superior fuel, while the legacy fleet still needs to have the old fuel. And this is not something that will be there tomorrow, but this is something to prepare for the more long-term future. Do you agree, Oscar?
Yes, I agree. And especially, I think it's a good point. And I think especially what is interesting is that some of these pathways, like HEFA, for example, or any, and the same holds for Fischer-Tropsch, any, let's say, straight alkane molecules. It gets a bit technical, but those burn a little bit cleaner, like a few percentage points, than fossil fuel or fuel that contains aromatics. And that creates an energy benefit. And that's especially interesting for ultra long haul flights. So you'll see this use case for the 100% use of HEFA fuels, especially in flights like London, Australia, or the Middle East, UAE to East Coast, or West Coast, US, depending on which direction you go. So like UAE or Dubai to Los Angeles is a ultra long haul flight, and if there's 2% efficiency benefits to be taken there by just taking 100% SAF, that's very interesting from an economic point of view for airlines. So that's an angle that will be explored and will probably be the first use cases of this 100% use in very new aircraft, very efficient aircraft that have a benefit of taking a little bit less fuel with them because it's such a long flight. And there you'll see proof points that can then be, let's say, extended to more general aviation and eventually segregated or like integrated system rather than this segregated flights.
Yeah, and long haul is also the segment where the benefits in terms of non-CO2 climate impact would be maximized. But I think we are going too much into detail now with the fuel composition. So let's leave that again out. And I think the more pressing short-term question is how do we get the first percentage points of the renewable fuel now into the system, and now again, you, Oscar, Sky Energy just released a report where you evaluated like production capacities that are announced that we will likely see or maybe not see in the near-term future, looking at the different pathways. So what are the key messages of that report?
Yeah, so it's a market outlook report we do every year. It's the 4th year in a row that we do it now. It's available online. You can leave your email and then you'll get it, I think, on the website. What we do is we do basically 2 assessments. One is until 2030, what happens, and then one is what happens between 2030 and 2050. And the assessment until 2030 looks at announced capacity in the market. There we see, and we assess these projects and we assess, okay, which are feasible and how are they progressing and are they delayed or are they on time and what's the capacity compared to the announced mandates or the requirement on the demand side. And we see one of the key messages is that over the years we've built projects, or the industry have built projects that could fulfill the 2030 targets if enough projects will take FID, final investment decision, over the next years. That those projects are 95% or so based on HEFA pathway, so waste oils and potentially sustainable veg oils. But beyond that, we see still a lot of, let's say, need for growth from, let's say, 2 sides. One is the biomass side, advanced biomass side, because that's the waste oils are basically limited in availability, right? That's one other message. We can't grow a lot further than what we see in 2030 just based on the amount of waste oils available in the worldwide market and the competition from that, for example, renewable diesel pathways. And so we need other pathways, and one of those is biomass, advanced biomass, and another one is e-fuels, the project that Gunnar was talking about as an example. And we will need to see the first demonstration or first of its kind commercial projects in the coming years to then develop the growth from 2030 to 2050 and enable and to reach the goals in 2050 net zero targets. We need a lot more technologies and a lot other pathways besides the HEFA pathway. So those are, let's say, the key messages that we see currently in the market. And then there's one other thing is that because we've done it 4 years in a row, we can now also see that every year we see that project get postponed. So when we did this assessment the first time in 2020, we thought that we had a lot more capacity online by today than we see today. So projects are too optimistic. That's one. But also we see that because policy is constantly changing, and so that there's some reluctancy from project finance to finance these projects. And that's why you see postponement of projects and therefore also lower capacity in the market today. And that's a risk if that continues to exist, that projects that there will not be enough projects in the market by 2025 or 2030, which will then not enable us to meet the demand that we'll then see both from policy mechanisms as well as the voluntary market.
Okay, thank you, Oscar. Again, you touched a lot of topics, and I think during the webinar we need to dive deeper into a few of these things, and one is so to say the limitations that we see with the heifer feedstock, also maybe some sustainability questions that we have there. But what I think is an apparent feature of your report, and we also did similar things now recently in Germany where I was involved, is that many things are focusing at the moment on the mandates, mainly that the mandates we see in Europe, and we see at the moment for the early mandates we have sufficient production capacity. So production capacity in first place, at least for the heifer fuels at the moment, but very clearly for the advanced biofuels and the e-fuels, it's at risk whether we will fulfill the sub-mandates and the targets that we have in that field. And now, Gunnar, Nordic Electrofuel is one of the companies that was moving early in that field, as you were highlighting. How do you see the perspectives there now? Do you think we will be able to have the first plants in time, and then also kind of deliver on the scale up perspective that we need towards the 2035, 2040, 2050 targets?
Thank you for the question. It's a very, very relevant question, and I think it's I guess the jury is still out there whether we would be able to make it. We certainly would like to take our part and have an ambitious rollout plan, but we see, as Oscar pointed out, I mean, most projects has been delayed. We also plan to have been on stream or come on stream earlier than we will now. So I mean that accounts for us as well. And I think we, what we are building here is the first of a kind. I mean, there's no plant out there producing eSAF at scale. There's some smaller demonstration plants, but that we're doing a first of a kind, I mean, means that the banks, the investor are anxious or skeptical. So it's been a long round of educating the stakeholders on that and on the financing side. For us, it's all about making a bankable project, and must be honest to say that's been challenging, but I mean we're sort of passing that now, and should be able to take final investment decisions soon and roll out. Can we sort of deliver on our plans? We can have a considerable part of what sort of market share of the mandates to come, but it's very sharp increases. I mean, it's approximately 600 tons needed in 2030, but sort of that rises to about 1.3 million in 2032, and going up to more than 3 million tons in 2035, and it's a lot of capacity. If you look on a full-scale plant will potentially deliver 50,000-60,000 tons. I mean, you need 20 plants for just the first mandate, and you can sort of quadruple that for the mandate in 2035. So I do not really see that this capacity will be met, but you know, the way of stimulating is through mandate. I mean, that will show that sort of you will get to a price which will sort of allow for that capacity to be built, and also in the coming years, from next year on, there'll be SAF allowances, which will you know, that sort of, you get, so the airline companies are getting subsidies, can claim these SAF allowances to pay for 95% of the added cost. So that's in place, I think, it's for the coming 3 years after 25. So that would also help and enable the airline companies to pay for this. So I think we'll get quite a bit of the capacity, but whether we get all of it, I think it's a bit of a stretch. I think so, and but let's hope for the best. I mean, we certainly will do our part in Nordic Electrofuel, and we have an ambitious growth plan we want to deliver according to.
And where would you see the main barrier at the moment? Would you say that technological readiness is more advanced than, let's call it, financial readiness? So do you think it's that we still have some unknowns on the technology side, or is it more the complexity of the projects and the complexity of financing it?
No, I think it's more the complexity of financing it. I mean, I think we've been sort of masters in doing due diligence by several companies running that on us, and we delivered very strongly on those. So we've proven that we do have the technology, but you know, banks and investors are anxious since this is a first of a kind. I mean, we are competing against any other, you know, particularly investor in us would be infrastructure investor. They can invest into a road or a bridge or you know, an airport for that matter, which is all proven and common and giving a decent return. So I can see that. Why should they take an additional risk on a first of a kind when there's a lot of opportunities to get your required rate of return on other projects? So I mean, that's the challenge we and all other are facing. So you know, we getting some support through the EU Innovation Fund, which is sort of compensating for some of that risk. But I mean, I think that's mostly the challenge. I mean, that this technology works. Yeah, that's proven that we have had some of the best engineering companies reviewing our project and found that this will work, and that we really are, you know, one of the best in class. So I think it's about getting the investor on board. I mean, we have some now, which we hope we conclude with, but I mean, we've been, I would say, wearing out some investors. So we had several investors which thought which have left us because they sort of found this too much of a challenge, and let's and as they say, a lot of invest in something which is easier.
Yeah. Okay. Oscar, I know that Sky Energy is also a small stake in the e-fuel pathway. Is this also your perspective that that the technology is there in principle, but it's challenging to realize the projects?
Yes, I think there are a couple of components that's still somewhat uncertain, especially around the CO2 conversion into CO. Let's not dive into the technical details, but there's components that are, yeah, well, let's say adjustments from known technology, but still adjustments. And that means that project finance still looks at it with a certain risk profile. So you need quite a strong collaboration between your tech providers and the contracting that you do with them. that then enables the comfort for the investors and the banks that it's secure enough. So there's always a challenge with these first projects, but I do believe, as Gunnar said, that many of the components and the most important components are quite well known, and it's a matter of scaling down for some of these technologies and scaling up for some others like hydrogen. But I do believe that it's a pathway that needs still development and will take a lot of learning. So which is always, that creates a lot of opportunity in terms of long-term scaling and benefits from doing the first. There is the ability that you generate the knowledge and can then do more efficiently future projects. But there's also a bit of a downside in not being the first and waiting a little bit longer, that some technologies may develop and may become a little bit more efficient. So that's the difficulty with these pathways, that some developers will wait and see, and others will take a risk of a first of its kind. And they all need to eventually create a bankable and economically viable project, let's say. And there's ups and downsides for both, to say, but I definitely see that this pathway can be done. It's more a matter of contracting and making sure that the risk is shared in the right way to enable these projects.
Okay, thank you, Oscar. So we are focusing now the discussion a lot on these fuel pathways and realizing projects, getting the volumes there. Certainly, we will also come to the regulations. But Gemma, now, what is your view here as an head of the environment division on these different options here? Do you see like sustainable aviation fuels like one big bulk of options that you have, or do you have let's say a merit order preferences on the individual options and pathways that we have there?
No, we don't have any preference about that. We just need to know if with new fuels aircraft will fly the same way. For example, we are very aware now of contrails, and we know that the more efficient the aircraft are, the more contrails we going to see. So for us, in our perspectives, it's really important to know if anything of the flight will change with the new fuels or new technologies. And this is what we have to be aware of that.
Yeah. So I think of course safety is absolutely necessary. So you don't mess with safety. In aviation, we have more than 1 million flights per year. So we should have less than one accident per 1 million flight at least. We should be better. And this high safety level has been established over time, also with a lot of learning. And therefore, there's also always some kind of risk coming with change. And we need to be very careful here. But on the other hand side, with the drop-in fuels at the moment, I would say we are also gaining experience. And at the moment, I think it looks very good that we can say that at least for these drop-in kind of fuels, we don't really see additional safety issues in the field so far. At least I'm not aware of this. You mentioned another important thing, it's the contrails. And you also introduced to this counterintuitive finding that more efficient engines may produce more contrails, yeah, and the cleaner burning fuels may also increase the frequency of contrails because they have slightly higher water content, hydrogen content, translating in more water vapor emissions. Still, we get the non-CO2 climate benefit. So can you elaborate a little bit on that non-CO2 perspective? And maybe also how this could relate to your field of flight level and routing?
Yeah, it's the next challenge we have ahead, because we have to be how which is the behavior between contrails and CO2. because we don't know exactly the behavior because with both factors, and we have to take into account. So now what we have seen is less CO2 with in higher levels, flight levels, but more controlled. So now, and how it's going to affect to our sector and how we are controlling those flights, because I was in a meeting last week, I thought it was, or last month, sorry, where DFS is developing a new tool to try to avoid contrails with it's a prototype, okay, but they are trying to develop this tool to try to avoid during the flight phase the contrail. But it has we need more milestone to develop this kind of information, and we need how it's going to affect to our service, the normal service, because we need in tactical reorganize the volumes, the airspace, the sector. We need to reorganize the position, the controller's position. So how it's going to affect to capacity? We have a high demand, and the demand is going to be higher, and then we expect a huge increasing of traffic, and how it's going to affect to capacity this contrails effect. So maybe this is a new paradigm. I think the pronunciation, I don't know, is paradigm. Maybe we are finding a new paradigm of how we are going to control and move all these flights in our skies with these effects, and how it's going to relation with CO2, because which is the biggest impact, CO2 or contrails. At the moment it has been CO2, but now is increasing the impact of contrails. So we need to study, to develop, and design new controller models.
Yeah, I think it's very specific thing in aviation that we have these two contributions to the overall climate impact, so the CO2 effect and the non-CO2 climate impact. And at the end of the day, for climate change mitigation, we need to act on both. So I think this is a very important message that we need to send out. There are trade-offs here and there, but very clearly acting on non-CO2 emission should not mean that we should not act on CO2 emissions and vice versa. And one thing that you have mentioned is the contrails. There's also NOx emissions. NOx emissions we cannot do a lot with the fuels. It's mainly regarding the engine emissions. And for the contrail effect, it's the thing that we can do something with the fuel. As we were saying before, likely the frequency of contrails, also persistent contrails that make the problems, will slightly increase. But on the other hand side, the particle emissions from the engines, they decrease. And this has a positive effect on the non-CO2 emissions. So contrails are ice particles, they grow larger, they sink down at a higher rate. This is why they don't have the same lifetime if we use a more clean burning fuels, and this is why we believe that a sustainable aviation fuel or fuel that doesn't contain the same amount of aromatics will improve these effects. But you were mentioning the air traffic management, and in air traffic management it's a different story. I would say for the fuels we have good knowledge. So at the moment from the studies, we can say it's safe to say when we reduce the aromatic content, then we will get the non-CO2 climate benefit. So I think there's enough knowledge out there to say this. There's also enough knowledge out there to say that if we avoid certain conditions at cruise altitudes by changing the flight level, that we also get a benefit there. But the big uncertainty is with the weather forecasts and so on. So we don't exactly know where to fly at what moment in time, and this is where the discussion is, and this is where also this trade-off between higher fuel burn at different flight altitudes come in compared to a potentially reduced climate impact. So, Gemma, what would you expect when you change now the flight levels, or usually it's a flight level change, height and altitude? Will this have an impact on the airport operations, like slot times and so on? So how do you think we can implement these things in congested air travel?
It's very difficult, is what I said before, because we need to be aware of capacity. Traffic is increasing, and when we were with Eurocontrol, the message is adaptation and avoid directs and just do what you plan. So this is the key message from Eurocontrol in terms of capacity. Okay, so that kind of new members that enter in the equation, like or factor enter in this equation, like avoid contrails, reduce emissions, that even they need opposite measure, flight levels higher or less, depending on. With the capacity, it's very difficult to know it, how it's going to change the operation, or how it will affect in the airport operation. It's true that contrails affect at very high levels, and maybe around the airport we could manage our air traffic. We could manage in a right way, I could say. But we need to see a global view and a global perspective for the whole airspace, especially when we are trying to implement this free route. And this is oriented by for reducing emissions and reducing CO2. It's very oriented for that, and we don't know, and we need to study. We still need to study that how it's going to affect for contrails.
Okay, thank you, Gemma. And now the same effect that may reduce the non-CO2 emissions, so lower particle emissions, also gives you an air quality benefit at the airports. So, Oscar, when you talk with airports, yeah, so US Sky Energy, you talk with airports, you talk with airlines, you talk with many stakeholders. When you talk with the airports, is the air quality benefit an argument there, or is it mainly about mitigation of CO2 emissions?
Sorry, the air quality definitely is a benefit, especially for airports, and then especially airports that are situated in dense city areas, right? So I'm based in Amsterdam in the Netherlands, and there's constant debate about the airport Schiphol here because it flies basically right over Amsterdam. And so if you can optimize and create, let's say, healthier air quality based on these improvements, I think that's a plus, right? Still, flying less and being very conscious of flying is important. But we expect that the industry will remain to exist, and then this can be a solution for, let's say, improving air quality, especially around approach and departure aircraft. And then, for example, electric taxiing or stuff like that is also a solution that is an on-airport solution that improves the air quality on and around the airport for both passengers as well as the employees on the airport. So it's definitely a solution for airports, both in a air quality improvement point of view, but also in a sort of a license to operate with more strict regulations around air quality and welfare, let's say, around that.
Yeah, I think so. So we are all aware that in the aviation industry, the main effect is really the fuel burns of the airlines. But for the airports, of course, what they do with their ground operation, it's also very important. You mentioned electric taxiing, single engine taxiing. So then the question, if you have the APUs running at the airport, or if you have access to socket which gives you the electricity and so on. These are of course also for the airport very important questions, and there the emissions where they are responsible are also kind of these kind of things, and the responsibility with the fuel burn is then mainly with the airlines. Now coming a little bit back to the fuel options that we have, and my perspective, and I also know that it's kind of Oscar's perspective, is that we have this fuel options, but we also have like different regional conditions. So one fuel option may be better suited for one environment and region than the other one. Coming very specifically to this Middle East. So Oscar, what would you say is the way to go for the Middle East? So on one hand side, it's also at a very nice location when it comes to the import of many, let's say, biogenic commodities. On the other hand side, it's would also be a center of solar power, for instance, and maybe also wind power. So,
Yeah.
so what is your perspective there?
I think that's exactly how I see it as well. I think there's a component of importing fuel that you can use regionally, or importing the feedstocks. It can be biogenic components that you can then convert into SAF in the region. But probably the biggest opportunity lays with renewable energy, right? And the consistently decreasing price of solar PV, and the ability to convert that into hydrogen is a huge opportunity to then produce large-scale eSAF type products. Maybe not today, because you still have the intermittencies. You rely quite heavily on storage options, which are a little bit less developed. So that's why specific regions like Norway and Sweden, where there is a more renewable grid or fully renewable grid available that you can operate on a baseload basis, on a 100% basis consistently, that is beneficial today. But over time, in 5 to 10 years, I think the price of solar PV and potential storage of intermittency, especially on a daily basis, so day and night storage, is something that will become available. And then the Middle Eastern region is perfectly well located and situated to benefit from that. So that's why we're also looking at that region to see, can we develop something there, and can we work together with partners to see whether we can take the initial steps to explore that. And that's beside things that you can do today. And one of those is especially important is policy creation, right? So the governments and kingdoms and other, let's say, governmental organizations in the region need to create the, let's say, boundary conditions that these projects can prevail, and for that the market needs to be there. And at the moment, the voluntary market is not strong enough to commit to very long-term, let's say, price premiums that are needed for eSAF. So you need some kind of either government support or very strong government regulations that force these airlines to use the fuel, or create incentives that it becomes interesting to produce it in these regions.
So let's come a little bit into the regulations, but still focus on the Middle East. So you said the airlines in a Refuel EU, it's the fuel suppliers that need to fulfill the mandates, and you also said that the free market, so to say, has induces some demand, but it's not a lot. So are we heading now to a future where Europe will be the center of sustainable aviation fuel consumption? And what is then the way forward for the Middle East? So is it like, in first place, for the first plants, exporting fuels to Europe because the mandates are there? Or is it the development of a domestic market, maybe driven also by something like local policies, passenger preferences, sustainability awareness, and so on?
Yeah, maybe I need to rephrase that a little bit. I think there is the voluntary market is very strong, and if you add that to the mandated market, there is a lot of potential there, right? So we see that the commitments that the airlines put on themselves are typically like 10% in 2030 in terms of SAF or decarbonization, and those are a lot stronger and go further than the mandates that we see in the market today. So there's a very strong voluntary market, which also has a strong role to play. At the same time, there's quite a bit of education needed in some regions where the topic of SAF is still new. And for that, it will take some time to allow these airlines to actually sign up to long-term commitments at the price premium with a risk, right? And let's put it like that. It's easier to do that in a situation where there is a mandate, because then airlines typically understand that there will be a market and they need to do something. But there is a very strong voluntary market also, potentially in the UAE. I do believe indeed that the initial project will compete because of the price premium. The product is quite a bit more expensive than fossil jet fuel, as we explained, and also the transport of that product to other regions is relatively small cost component on the production cost. So there will be a worldwide competitive market on sustainable aviation fuel, and some fuels will flow into markets that are mandated, and other fuels will flow into voluntary markets because they allow for different regulations or different fuel profiles or different production pathways that may be not meeting the EU criteria, but could be very well sustainably produced under other conditions or in different regions in the world. So I think there will be different marketplaces, but in the beginning, indeed, especially e-fuels will likely flow into mandated markets because of its price premium. That's indeed an element that we believe, and for that, the European market signal is strongest. But it's not rocket science, and we have seen these policies develop quite quickly. So it's very easy that these regions can also develop their own policies in similar fashion in the coming years.
Yeah. So you mentioned the e-fuel sub-mandate that we will have in Europe. Maybe you can say a little bit more about this. So my understanding is there is no buyout, but there will be fines. So how is that implemented?
Yeah, so maybe the Refuel EU mandate is basically a piece of legislation that forces fuel suppliers to supply sustainable aviation fuel. And that's a percentage of the total volume that they supply, which grows from about 2% in 2025 to 70% in 2050. And within that percentage, there's a percentage that needs to be covered by e-fuels, power to liquids, that grows towards 35% in 2050, basically half of the 70%. And that obligation is put on fuel suppliers, but the airlines are obligated to use the fuel. So you can't go do any tankering coming into Europe. So everyone flying out of Europe needs to refuel the amount they need. And for that, because the fuel suppliers are mandated on the SAF, every flight is eventually including that SAF molecule. And the SAF sub-mandate or the eSAF sub-mandate is a specific target to stimulate eSAF besides the products like HEFA or bio-based pathways. So that's the structure, and it's a structure that then pushes the fuel supplier to produce these fuels or to get access to the molecules and then sell it to the airlines, and therefore the final price premium is covered by the flying person. Whereas with incentives, the premium is basically paid by the taxpayer, which is, I think, the mandate in that sense is a fair system because it's a polluter pay principle, whereas the incentive system is more of a general public pays for innovation, and it can be done in an early stage to let's say kickstart a new industry, but it's a risky long-term strategy because then the taxpayer pays for decarbonizing a specific industry.
Okay, thank you. So Gunnar, coming back a little bit to the Middle East perspective. Now you come, companies called Nordic Electrofuel. So you come from a background where you have very nice hydropower availability, which makes your life maybe a bit easier for the first projects. So how do you see it when you compare like your Nordic situation with a low-cost solar power situation that we might find in the Middle East? Not to say that in the Middle East there's also some nice spots for wind energy. How do you see that, these two different types of e-fuel production, having access to low-cost baseload electricity, as in your case with your first plants, and then the more intermittent renewables that we also need to go for the big scale in the future?
Well, I see it very interesting. I mean, we started the reason we started Nordic Electrofuel was that we saw the need for eSAF and e-fuel, and we saw that this should be done in Norway, where we have the highest rate of renewable power and where you do have surplus power. And the great thing with hydropower, it's like a battery without any leakage. So you can tap it whenever you like, and therefore we can operate 24/7. So of course that's the beauty. If you can operate 24/7 instead of operating say 12 hours a day, you can build a half of the capacity you would have built if you for 12 hours. So going to the Middle East, and I've been having, and my team as well have been having discussions with several of these countries. So somehow they recognize us, and we see that area is very interesting because the lowest price of renewable power in the future will be in the Middle East. So for that reason, obviously, this market for our expansion is definitely very interesting for us. It is a question of this ability to how well can you operate it? Is it sort of like, because you have a combination of solar and wind, but it's not that when the sun goes down, the wind steps up. So you would have periods where you cannot produce and obviously need to add a higher hydrogen capacity so that you can sort of run the Fischer-Tropsch part continuously, but you be producing hydrogen for storage to tap when the sun has set and the wind is not blowing. But still, I mean, it's of course interesting, and then again, it's also a question: will there be a market there? I mean, will this region has a big aviation industry. Would we be producing for them, or would we be producing to fulfill mandates in Europe or somewhere else? I mean, that's some of the question we need to ask. But for sure, the Middle East would be in a quite ideal place to operate, and also it's a significant amount of CO2 you could source as well in these countries. And I understand from talking to several countries that they do understand the need for getting up a SAF industry. That do see the need for increasing SAF on their domestic or airline, which are based out of these countries. So I think it's an interesting area for us for sure.
Gunnar, you mentioned CO2. So I believe everybody in this field agrees that if we want to bring the e-fuels to their full potential, we need some scalable carbon supply like their direct air capture. So, but do you see carbon availability in form of CO2 or other carbon sources as a bottleneck also in the near term for the first projects?
Not for the first project. We'll have CO2 available, but of course the one owning biogenic CO2 is, you know, recognizing that it has a value. So I think we're seeing an increase in the pricing of that, and unfortunately that will sort of filter into the end price. But I would say that for the initial 5-6 plant, there's enough of biogenic CO2 around, and I think there's some hubs with a lot of CO2, but then again you need to have a efficient transport to send them on ships. So but I think that's doable. We're also looking into direct air capture. I mean, we see that eventually one will tap the sources of CO2, and one need to go to direct air capture. There's a lot of good initiatives in that area, and many are coming behind sort of the very well-known, like which Climeworks and Carbon Engineering. There's quite a few newer initiatives. So I think it will be coming, but it will be taking quite some time. Yeah, I mean that's not, direct air capture is sort of not for the next 10, maybe not the next 15 years, but say from 2040 we can hopefully have considerable amount of CO2 also from directly from the air.
Okay, thank you. Thank you also for your optimism there. I'm also optimistic, and you mentioned companies that are driving forward with the technology, and they do it from a different perspective at the moment. So they get their money at the moment for carbon capture and sequestration. So I think this is important that these companies have another sector at the moment where they can kind of grow their technology, and yeah, I really hope that they are successful there. But of course, there are risks and unknowns coming with it. One very general remark, and this doesn't go to the panelists now, this goes to the audience. So far, there have not been many questions in the chat. So please, if you have questions to the panel, please type your questions into the chat, and we are then more than happy to answer them. Getting away now from the very regional perspective of the Middle East, going to the global perspective, and to my understanding, the waste oils and also the plant oils that we are converting in the HEFA pathway, they are globally traded commodities. So they are shipped around the globe, and this means there is also then global competition, cross-sectoral competition. So just these 2 months, 2 reports have been published, one by Transport and Environment, warning that what we can do with used cooking oil, or what we do at the moment with used cooking oil, with the competition with the biodiesel sector, already may introduce some problems. Then also the US Department of Agriculture, having an eye on severe growth of US renewable diesel production capacity, also warned that we will see enhanced feedstock competition at a global level for the upcoming year, also for what the US is doing at the moment with the renewable diesel side. So Oscar, what is your feeling? Are we already overdoing it, or so do you think it's that the current growth in conversion capacity is matched with, let's say, the growth rate that we have in developing sustainable feedstock for HEFA fuel production?
I think it's already quite restricted, let's say, so there's not a lot of room for growth. If all the projects that are currently announced will realize, we will use all waste oils that are available in the market. So there's limited availability for growth on that side. There is some potential on what they call, let's say, low ILUC. So ILUC is a new word, indirect land use change. It's basically cover crops or crops that are rotationally with food crops. So you don't want to use food crops because of the food versus fuel debate and the sustainability issues there. But there is a potential to optimize land use without cutting down rainforest. That's a very important element where you can use, for example, deserted land or degraded lands or land in rotation with other crops, where you can potentially grow, let's say, oil-rich crops that could be a feedstock for these pathways. It's, however, very early stage, and there's a lot of investments and education needed for farmers to start using these crops. So we don't expect a lot of potential there from before 2035, 2040 maybe. But then it could start to play a role. But I still expect it. On waste oils, you potentially can come to, let's say, 5 to 10% of global demand for SAF, and then beyond that, potentially 10 to 15. You can boost it to 10 to 15 if you start using these cover crops, and that's about it. And all the other pathways need to come from alternatives. So again, to come back to the Middle East, there's little potential for these crop-based systems. So I would focus on these regions where there's a lot of strength, and that's more on the hydrogen side and renewable energy side, in my opinion.
And yeah, now Sky Energy, when I go to your website, I see that you have stakes in all of these pathways. So you have a plant under development, under construction, but you also have an activity with advanced bio mass conversion in the US, and your e-fuel activity in your home country. So is that then also kind of your growth strategy
Yeah.
to have a foot, so to say, in the heifer market to be able to deliver volume, but clearly focus in terms of long-term growth than on the other pathways that can be scaled more
Yeah, that's
sustainably?
basically how we see it indeed. Yeah. So if we can invest and collaborate with players in the HEF industry, we're also interested in that. We just don't see a lot of growth potential beyond 2030. And for the beyond 2030, a growth strategy is based on these other pathways. And that's why we're aiming to develop the first of its kind units, for us, first of its kind units in the phase prior to that, and have a pipeline of projects to be able to scale those in the 2030 to 2040 timeframe.
Yeah, especially in your position. I mean, you're evaluating various pathways. So of course, we read a lot about breakthroughs here and there in the media, but we also read a lot about failures. Also, with the advanced biomass pathways and waste-based pathways, also in recent time. So you are betting a bit on a biogas-based gasification pathway. I don't want to go into the details, but which may be a little bit more on the robust side. But how do you see that fulfilled with the advanced biofuels in terms of, let's say, technology readiness, yeah, feedstock supply risks, and so on.
Yeah.
So
That's a very good question, very detailed. I think in terms of like advanced biofuels, there's two big issues. Conversion into SAF, technology-wise, and preparing a feedstock that is clean enough to then go either into syngas or into a biocrude like oil product and then upgrade that. But challenging because biomass comes in a lot of different forms, and straw is a very different product than woody biomass, right? So it's challenging to let's say compare those. and to convert that into fuel. So there's a lot of development still ongoing. So it's difficult to pick a winner today, but there are progressions and some developments. However, there's also a lot of failure. Like recently, Fulcrum, I think, announced bankruptcy, which was one of those projects that looked at gasification of municipal solid waste and the biomass fraction of that into SAF, and was in the end failed to do so. There are like the pathway that we find quite interesting is, for example, RNG. So renewable natural gas is a pathway or a feedstock we see as a feedstock, because RNG to SAF is relatively easy. It's a gas to liquids plant, which is well proven in the industry. And RNG production through anaerobic digestion is also quite well proven. So combining these two is something we find quite interesting and are looking at as a pathway to avoid that technical risk, and also to see whether we can scale up based on a pathway that is already rolled out in the industry quite extensively. So yeah, but it's a delicate topic, and there's many ways to approach it.
Thank you, Oscar. So there has been one thing in the chat saying that it would be helpful to put all these questions on the screen. So I can just say from my perspective now, being here at the panel, so far I don't see any questions. So I just hope that there are not questions somewhere hidden that we don't see. So if you have any questions, please ask. And to the organizers, if there are questions but we don't see them, please make them visible to us, because so far we don't see questions from the audience. So
maybe
please,
they mean your questions, Valentin. I don't know, but then that's going to be a bit complicated.
It's would need to type and talk with you at the same time. I can do it, but no, let's keep it relaxed, and let's don't do this. Yeah, when you were saying you were talking about advanced biofuels just lately, and so sometimes I believe that methanol may be a key platform molecule here. So to develop something which is maybe easy, which can also be used as a feedstock for the renewable chemicals and as shipping fuel and so on. How do you see that, maybe Oscar and also Gunnar, there's synergies that we may have with other sectors? Do you see a role there, or would you see it's more like focus on the aviation fuel and don't care too much about left and right, at least in early upscale?
I definitely see a role there. I think it's very interesting to look at these platform molecules like ethanol, but also methanol, as you mentioned. Also because you can go through to methanol both through a bio-based pathway as well as an e-pathway. So you can make multiple products from multiple feedstocks. It's, however, there's a risk in realization in terms of project on project risk. So these methanol industries and markets need to be, let's say, commoditized first before you can invest in a project to upgrade that product. So it will take a bit of time, but it is an interesting. It's definitely an interesting molecule as an intermediate to avoid that or to collect larger volumes and be able to have let's say, a scaled up facility at a centralized location, which is then more efficient than all these smaller facilities.
Okay, thank you. So yeah, it was about my question. Now this is clarified, so thank you. But I try to type, and it's difficult to type and moderate at the same time. So please accept that I'm not doing it. Now with 20 minutes to go, now coming back a little bit to the targets that we have now, the 2050 climate targets. So what is your perspective, starting with Gunnar? Are we on track towards these things, and what are, from your perspective, the most pressing needs that we have? So what is most desperately needed now to move further on towards these targets?
I think we are probably somewhat delayed, but still we have 25, 26 years to go, and I think there's time to catch up, but we sort of need to react. I mean, Oscar said it that sort of most of the projects they were viewing were delayed. There will be a challenge, I think, to finalize all the mandates. It's very clear that the low-hanging fruit for sustainable aviation fuel in terms of HEFA have limitations, and it's sort of up to e-fuel to be one of the coming sort of pathways, alcohol to jet another, and for none of these businesses there's any commercial scale plant of yet. So there's definitely challenges to come. I think sort of one of the biggest obstacles we're facing is I would say the financial side. So although we already got sort of support from the EU Innovation Fund, I think there may be a sort of government should work on how to stimulate this industry and to get more capacity here. I mean, we cannot sort of come to a situation where we see that the industry is not meeting the target. I think that the global warming threat is so severe and so risky for the world, and we really need to comply with the targets. I also think that the targets are laid in a very sort of suitable way. I would say that it's a gradual build-up, and I think as well when we can get to bigger capacity, it's easier for us, and then you will have the learning curve done by the banks and by the investors, and then it would be easier. But no, I think it's really critical that we in the coming years are seeing that now projects are coming up as they should, and that we deliver with this plant, and that is sort of we have the funding sort of willingness to do this. I mean, I was at this, Oscar and I attended a conference three weeks back where you had AFRI consultant, one of the biggest consulting company in the world, and which said that, well, the money is not around to fund all of these projects, and that's a area one need to address in order to get that. I think sort of the shortage is not so much on the technology. I think it's more on the funding and financing side, and I think that's sort of something the governments, the EU Commission, in the US and the Middle East, one need to be aware of that and come with some measures which can sort of counteract that.
Yep. Thank you, and I share your optimism. I've been on the same conference, and
Yes.
somebody else said there is enough money around, but it's not flowing into at least the e-fuel and advanced biofuel markets at the moment for space. I would like to continue a little bit on this, but now we get the first question from the chat, and it's on alcohol to jet. You were saying there's no commercial project. I maybe you're right, but it's around the corner. I would say the first big alcohol to jet plants are around the corner. And from a technology perspective, I would personally say, and the question will go to you, Oscar, that the conversion of something like an ethanol or methanol to jet fuel is something where we have likely nice technologies at place. But of course, cellulosic ethanol is another topic. And Oscar, maybe you can comment on these two things. I'll go to chat in general, where you see the perspective, and very specifically then for the cellulosic second generation ethanol production.
Yeah, so I think Elko to Jet is, so there's a first plant built in the US now by LanzaTech, LanzaJet. That's a commercial scale facility. I believe that's a relatively, I must be sensitive there, but easy technology, right? So it's a refinery type technology that can convert ethanol into SAF. It's a number of steps, but it's quite well understood. So there's not a lot of risk there, in my opinion. The risk indeed lays, as I think I mentioned before, in converting biomass into the intermediate product. So that same component holds for the commercialization of cellulosic ethanol, where cellulosic ethanol starts with byproducts from biomass, like cellulosic material, right? It can be straw, can be woody biomass. And then you need to unlock the sugars, which then the sugars can be fermented into ethanol. And that, especially the unlocking of sugars, needs quite a bit of energy. So that's one element that is difficult. You can use the lignin, which is a byproduct, to do that. So, but the overall yield, so the total percentage of biomass into ethanol is about 20% or so. And that means that, and then ethanol to SAF on the mass basis is again about half. So overall, you reach about 10%, a little bit more, that can convert biomass into SAF. And then you need to produce 100,000 tons, which is typically a size that is commercially attractive for SAF production. You need 1 million tons of biomass, and that's a lot of biomass. So there are challenges on the technology side, but there are more challenges, in my opinion, on the supply chain of biomass gathering, which is quite a big challenge. And that is one of the reasons why some of these projects have unfortunately not succeeded. So POET DSM was a project in the US, Clariant was a project in Romania, in Europe, that all, let's say, eventually closed the facility based on, or more or less stopped producing, mostly because of these supply chain reasons, and some also technology reasons, but those have been the economic challenges, let's say. And I'm not saying that it cannot succeed, but it's definitely challenging for the time being.
Yeah, thank you for the answers, Oscar. So yeah, getting the feedstock together, and then also in consistent quality. So this is one of the issues. I need to say that Sunliquid was the plant, and Clariant is a company which is still very alive.
Oh yeah, of course. Yeah. So sorry. Yeah. So Clariant is a very respected big company that is very much alive, for sure. But their second gen ethanol project, I must say that is indeed a Sunliquid project that is not so much alive. Yeah, sorry about that.
There's another question now, and I don't know who wants to answer this, but maybe also Gemma. What progress has been made technologically? So this might be for the fuel production pathways, but you can also answer this from for general the aviation perspective, and can airlines buy carbon credits to fulfill obligations?
Yeah, with carbon credits, I know the expert. I know that there are two programs, ETS and CORSIA, where they can buy depending on the country. But I can't say anymore because I'm not expert about CORSIA or ETS. But regarding technological progress, there are different perspectives from the ATM, from the management, the technology technological progress has been huge, because there have been a great eruption with PBM, the new ways of design and flight procedures that made we can make more efficient route with the eruption of this technique. So with regarding ATM, PBM is the greater progress. But for example, aircraft has been a great progress, because since early of 60s where commercial aviation start, nowadays aircrafts are 80% less pollutant than before. So the progress have been made. It's not about the new objective. So since start aviation commercial or commercial aviation, since the start, they have improved the aircrafts and the engines, and this is a fact. So all the sector have been working on that progress.
Okay, yeah, thank you. Let's be unfair to Airbus and Boeing. Yeah, let's say that they don't have aircraft development program at the moment, neither Boeing nor Airbus. So progress on that side is slow. But I think with sustainable aviation fuel technologies at the moment, there is a lot of progress, also because of the boost of the interest in the field. So many players are coming in, so many people try to innovate. So I would say there is, at least with the fuels, there is a lot of progress at the moment. I want to answer the next question, the role of sustainable fuels. We have addressed this at the very beginning, and the conclusion was they are more expensive, yeah, but at the end of the day, they are absolutely needed to get to climate neutrality in the long run. So for that reasons, they are absolutely essential, and also because we don't have another alternative than the drop-in fuels at the moment in aviation. We cannot simply go electric, and likely also the hydrogen option will take time. So this is why the sustainable fuels are so important. But the next question I would again open for the panelists. Who should drive the innovation? So is it the regulators, or let's say also governments with specific programs, or should it be the operators? So this, of course, could also be understood not only from the fuel perspective, but also from the operational perspective. So maybe start with the fuels. So where do you see who's driving the innovation? Is it
Well,
the companies, or is it the regulators, or is it the interplay of both?
it's a question of all of us.
Yeah.
I know the regulators must, I think, in my opinion, regulators must start, but we have promote that kind of regulations, because during this webinar we are always talking about the extra cost of e-fuel, about SAF, but nobody, we don't mention about the extra cost about the climate change, because it's going to cost a lot. There are research, and they said that around every year, more or less, the disruption due to climate change cost around, I think, is more or less 60 billions of dollars per year. So we must be aware of that this extra cost must be compensate the other one. So all the actors, all the stakeholders must move toward this objective, and who is striving, we must. It's mandatory that regulators start with this movement, but we must be in the side. Our position is not to wait, so we must be reaction.
And then in the fuel sphere, how do you see the interplay of regulators and let's say fuel producers, technology developers? Yeah, maybe this is a question to Oscar or Gunnar.
Yeah,
I think it's very important, because in the end, like, the technologies come from tech providers, right? So the innovation on the technology side come from these tech developers. However, the market to then succeed needs to be established by strong regulations. And that does not mean subsidies per se, right? But you need to create a playing field where these projects and new innovations can succeed. So with things like sub-mandates or specific blending requirements for specific pathways, you can create innovation on ESAF. And then there's the market that needs to solve for the most efficient pathway and hydrogen use, or the most efficient use to convert biomass into something. So it's a very delicate balance, but in the end, the innovation comes from tech providers supported by policy that enables that and creates segregated markets where these projects can then succeed.
Do you agree, Gunnar?
Yeah, I totally agreed. I mean, the stimulation comes from the mandatory blended requirements, and it's the tech providers, and I see it's a lot of new developers coming out, bringing the innovation which are enabling production of ESAF and also other type of SAF to meet the mandates.
Yeah. So now we have the situation that we have only 2 minutes to go, and the questions pop up one. I take another one. There was a question if SAF can be blended with conventional fuels, and if so, what the implications are, because we discussed this below. They can be blended up to a level of 50%, which is sufficient for the moment. So it reduces then, of course, the CO2 emission, but it also has a favorable impact on non-CO2 emissions, non-CO2 climate impact, and air quality emissions at the airport. One question I want to ask again to Oscar, the fuel expert here, and it's about the waste management strategies and international airports. So do you think the scale, is it interesting enough to have like waste to liquid, waste to aviation fuel projects at the airports that make a reasonable contribution here to the decarbonization?
I think there's a couple of components, like waste management on airports is a waste issue. That's always important, right? That's a more of a, but the emissions from that side, if you purely look at CO2, the emissions from fuel use is about 95% or more of the emissions in for airlines, right? So the waste emissions on airports are rather limited. And then there are synergies with these to be made where you can use the waste for SAF production. That technology is also still somewhat challenging, and we see difficulties in upgrading, let's say, the waste into a clean enough product that can then be produced into SAF. So that's a challenging pathway, but there's a lot of technological development ongoing in that space.
Okay. So 1 minute, I just take one more question. It was about performance and efficiency with the traditional fuels. The SAF fuels are comparable and slightly superior even in the performance compared to the traditional fuels. But now it's 1500, so I think I need to thank the panelists. I very much enjoyed the discussion. There's still open questions here, so how airlines can manage the transition period, and also the commitment to fly net zero by 2050, and so on. I think these are two big questions that are open. So this is food for thought for everybody. This is a lot of subjects now also here for upcoming webinars. But I believe we are done for today. So again, thank you to the panelists. Thank you also for inviting me here to moderate this. And from my side, I wish everybody a good day. See you here or there.
Yeah, I think that's the end of our webinar. As much as we would like to entertain all the questions, but we don't have much time. So thank you everyone for joining us. And on behalf of Saudi Airport Exhibition team, I would like to thank our speakers and our moderator for your insightful contributions. I hope to see you all again soon, guys. Thank you everyone and have a great day.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.